Hi, I'm Paul, this is Science That Sticks, and today I'm actually at Felbrigg House in North Norfolk. And I'm in a very echoey room, so the sound's going to be a bit dodgy, but this is a great little exhibit. Behind me is a little pool that demonstrates how weathering and erosion takes place and how the flow of water can move matter from one place to another. But there's more to it than just this. This is a fantastic example of a ripple tank. So I'm going to do a little bit about waves. Bet you didn't see that come in. So let's go back over here. Let's have a look at the ripple tank and what we can see. Or at least I'm going to call it a ripple tank, but it's just this exhibition. So let's go for it. So one of the things that makes this a great exhibit for physics is the fact that you can clearly see all of the waves. Because you can see all of the waves, the lights that are shining on it are reflecting off of the shiny surface and making the definitions of the wave very, very clear. And that's fantastic for calculating wave speed. Now the wave equation is wave velocity, which is in meters per second, is equal to frequency times the wavelength. The other way we can look at wave speed is simply by measuring how fast something has travelled over a set distance, which is why the good people have allowed me to use one of their rulers. So we'll do both, and we'll do the mathematics when I'm back in front of the board, and you can see exactly what's actually happened. So you should be able to see the ripples moving, and what I'm going to do is I'm just going to move a few of these stones so that we can see some really nice waves moving across. Now if I place the ruler just inside of this, we should be able to see the waves moving, and I'll zoom us in a little bit here, so hopefully this will work really well. Yes, it's working tremendously well. Now, there's a couple of ways we can measure this in real terms. We've got a 30 centimetre ruler, and what I'm going to do is I'm going to count 10 seconds. Okay, so 3, 2, 1, 1, 2, 3. What I'm going to do at that point is I'm going to slow that down, and I'm going to count how many waves pass by in those 10 seconds, and that will give me the frequency. So if I divide that, so 1 divided by however many numbers went past in 10 seconds, that gives me the frequency. Once I've got that, I've then got my wave speed, so I've got a distance and I've got a time for one wave to pass by. So there we have it. Hopefully I'll have some data with which to be able to do the mathematics of it, but essentially, even if I don't, let's just go through it one more time. This is an excellent demonstration of how we can get waves to pass through, and we can see the waves really clearly. Not only can we see the waves really clearly, there are lights shining on it, and the light's bouncing back through the wave so that it gives us that definition. If we have a set point 30 centimetres in this case, we can find out how quick the waves are at passing. So we've got a distance, 30 centimetres, and we time how long it takes for one wave to pass across. And of course, 30 centimetres divided by that time would give us the speed in centimetres per second. So we'd have to change the 30 centimetres to metres by dividing it by 100. So it'd be 0.3 times whatever time it is. That's one way of doing it. The second way is to look at frequency. So how many waves pass a point in a certain time? And then we multiply that by the wave number. Not the wave number, the wavelength. So how far is it between each wave? Well, that's easy because we can pause the video and we can measure the distance between the two waves. This is Paul. Hope you've enjoyed that. As always, stay cool. Take care. Bye-bye.